All right, here are your solutions to the study guide for logarithms. So first, do you know how to rewrite a logarithm as an exponent or vice versa? So if you have a logarithm, what's inside the logarithm? The base and the exponent. What's inside the logarithm equals the base to the exponent. How about the other direction? Well, a logarithm is another way to write an exponent. So the exponent 2 can be with a logarithm with a base of 14. That exponent y can be written as a logarithm with a base of 8 with x inside. Evaluate a logarithm. Sometimes you need a calculator, sometimes you don't. Remember, a logarithm is an exponent. So 6 to what exponent is 36? 2 to what exponent is 16? 2 to what exponent is 8? This one's negative 2. You could also use your calculator and go log 16 divided by log 2 and you get the same answer. How do you find the inverse of an equation? So we're going to write x equals and then negative 2y plus 1, subtract 1. Now the logarithm's isolated. Write down what's inside the logarithm, and then the base for ln is e to the exponent x minus 1, and then there's the symbol. You're going to divide by negative 2 and get your answer. Same thing here. We will inverse this. X equals y plus 2, take away 3. So we're going to add 3. Now the logarithm is isolated. So what's inside the logarithm? The base, and then the exponent, x plus 3. Then to get y by itself, subtract, and you have the inverse. All right, can we expand the logarithm into multiple logarithms? So if I see multiplying, I'm going to add, make sure it's ln for each one, and then subtract for dividing, and then the exponent 3 goes in front. I'm going to rewrite this as 5 to the exponent 1/2 so you can see it. So to expand it, it would be ln x plus ln 5, and then the exponent 1/2 would go in front. Here we have multiplying, so we're adding, and then the exponent goes in front. Here again we have multiplying, so we're adding, and the exponent goes in front. Using properties in the other direction, one logarithm, and then if you see adding, you multiply it. So 3 times 7, and then divide by x, one logarithm. Here, if I see a number in front, it's the exponent, so it's x to the 6th times, again the exponent, z squared, and then divide and y. Think of this as 1 dividing. Now this is 1/2. So if 1/2 is in front, you'd have the exponent 1/2, which was the same as square root. So this answer is the square root of u divided by y. So again, one logarithm. So adding means we're going to multiply it. So it's x to the 4th times y to the 8. Subtracting means dividing. So in the denominator will be z to the exponent 2. I know my z's and 2's look a lot alike. All right, solve this equation. Step 1 is to isolate the exponentials. We're going to add 9, and then another way to write p is as a logarithm. And then we're going to use our calculator to evaluate that. So I'm going to go log 23 divided by log 10. That's 1.362. In number 20, I'm going to divide by negative 2. I'm just going to write that as positive 4.5 or 9 over 2. Another way to write that exponent, k minus 7, is a logarithm. The base is 20, and inside the parentheses is 4.5 or 9 over 2. Add 7, and then use your calculator. So I'm going to go log 4.5 divided log 20, and then plus 7. That's 7.502. All right, find the inverse of these. So again, to inverse, I go x equals, and the x becomes a y. All right, the inverse of dividing by 3 is to multiply. The inverse of multiplying by -1 is to divide by -1. Now the exponential is by itself. Now, what's another way to write that exponent? As a logarithm. And then inside the logarithm is -3x, and then the symbol for inverse. Again, we're going to inverse this. I'm going to add 2. Now the exponential is isolated. Another way to write that exponent y is a logarithm. The base is 3, and inside the logarithm is x plus 2. And again, the symbol for inverse. All right, can you solve a logarithmic equation? I have 1 log on the left, 1 log on the right. So that's -3x subtract 9, 8 subtract 2x. I'm going to add 3x to both sides. So -2 plus 3. I'm going to subtract 8. Now, if you plug -17 in, this has to give you a positive value. Now, if I went -3 times -17, a negative times a negative, that's 51, take away 9. So it does give you a positive value because a negative times a negative is a big positive number. All right, 24, divide by -10. This one is when you have a log equaling a number. Now that I isolated the logarithm, what's inside the logarithm? The base and the exponent. So 2 to the exponent 4 is 16. Subtract 3 and you have your answer. And then make sure 13 gives you a positive value inside the logarithm. All right, a little story. A country pledges to reduce its annual CO2 emissions by 4% per year. If the emissions in 2020 are this, which are metric megatons, in what year will the maximum allowable emissions be this? So we're going to use this formula because it's decreasing. So A in this case is going to represent the beginning amount, which is 2,580. It's being reduced by 4%, so R is 0.04. I don't know T, but I want to know when that's going to be 2020. So there is the setup. I'm going to divide, and I'm just going to leave it as a fraction and put that in the calculator. 1 subtract 0.04. That's like $1. Take away 4 cents. That's 96 cents. And now we're ready to write it as a logarithm. So I'm going to write this over here. So the exponent t can be written as a logarithm where the base is 0.96, and then inside the logarithm is 2020 divided by 2580. All right, I'm going to type that in the calculator. So I'm going to go log. Oops, I already have a parentheses. All right, log and 2020 divided by 2580, close it, divided by log 0.96, and that gives me about 6 years. I'm going to round to 6. So the question is, in what year? So we were at 2022, so in year, add 6, 2028. the emissions will be 2020 MT. All right, let's try this story. A rubber bouncy ball is dropped from a height of 158 centimeters. After each ball, the ball returns to a height 18 less than the previous maximum height. After how many bounces will the maximum ball height be 60? All right, so similar to this one, where we're starting with 158 and going 1 subtract the rate, which is 18%. And then I want to know when the answer is 60. I'm solving for t. So I'm going to divide by 158 and subtract. So $1 take away 18 cents. That's 82 cents. That's the base. And then you're dividing. So another way to write t then is as a logarithm, and the base is 0.82, and inside the logarithm is 60 divided by 158. How would I type that in? So, and if you're at home, you would just use Desmos.